So for 5-3, we're going to take what we did with perpendicular bisectors and with angle bisectors, and we're going to apply it to triangles. So the perpendicular bisector of a triangle looks like this. So we're going to make a sketch, and we're going to do the real perpendicular bisectors with our compasses in just a moment. Okay, so you're going to draw your triangle. So draw your triangle like I did in red. Then you're going to put a point at about the middle of each line. So where my green points are. Going to put a point right about at the center. So we are making perpendicular bisectors for each of our triangle lines. So there's 3 lines. I'm going to get 3 perpendicular bisectors. They're going to cross, if you make an acute triangle, they're going to cross somewhere in the middle of your triangle. We're going to be talking in this section about concurrent lines. So concurrent lines are lines that intersect at a point. So if I'm talking concurrent, I mean that lines that intersect. And we're going to talk about a couple of special points. So concurrency of perpendicular bisectors of a triangle is the special point where the perpendicular bisectors intersect. So the perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices. So you guys see these dashed lines here? So B to P, this little blue dashed line, that is the same distance as A to P, same distance as C to P. So the point where the perpendicular bisectors meet will tell you how far away from your vertices you are, and it's called a circumcenter. So all right, so the way I remember circumcenter is circumcenter and perpendicular. They are really long words, and circumcenter is the longest out of these triangle central point items, so they go together. Perpendicular bisector, circumcenter. So if you're ever in the matching, long word goes with long word. Circumcenter and perpendicular. That's how I remember this. Okay, so let's look at how we're going to use this property to help us find distances within our triangle. We look at example 1. The perpendicular bisectors of triangle ABC meet at D. If I use the circumcenter property where they're all the same distance from the vertices, I can say, I'm back to the notes, guys. I can say that this distance from A to D is congruent to the distance from D to C, is congruent to the distance from B to D. So if I have a perpendicular bisector point of concurrency, a circumcenter, then I can say that each of these 3 things are congruent. The next thing, if I'm looking at my picture, we know that if I'm a perpendicular bisector, this is 90 degrees, as well as that is 90 degrees. Perpendicular bisector. And it's a bisector, so that this side is congruent to this side here. If the whole thing is 24, then just a portion of that is 12. So then if I were to pull this little triangle out, I'm going to highlight the triangle I'm going to take out. Highlight them, not with crayon. Oh, we'll do crayon. Okay, so I'm going to take out and redraw this little triangle right here. So he's going to go, he's got a 90-degree angle. This side is 5. This side is 12. I'm looking for side AD. I don't know what that is. Which theorem are we going to use to find it? Pythagorean Theorem, right. So Pythagorean Theorem says a squared plus b squared is equal to c squared. And in this case, it's 12 squared plus 5 squared equals our unknown side squared. 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. And the square root of 169 is equal to 13. So this side here is equal to 13. So DC must also equal 13. Because those distances from the vertice to the center point are congruent. All right, since the circumcenter is equidistant from the vertices of a triangle, we are going to use the circumcenter as the center of the circle that contains each vertex of the triangle. We say that the circle is circumscribed about the triangle. We're going to construct a circumscribed circle about a triangle. We got our construction stuff here, so let's go ahead and do it. So let's first make a triangle. So after we make our triangle, we're going to make our perpendicular bisectors for each side. It's a good thing we practiced that today, right? Otherwise, it'd be super hard to do this. So, perpendicular bisectors. Perpendicular bisectors of each side using your compass. So create a perpendicular bisector for each side.
So we should take that. No, this one's yours. It's really very too easy. Look.
Make sure your perpendicular bisector goes all the way across so that you can see where they're going to intersect.
Oh, God. Oh, no.
Why is that?
Oh, no, I'm really confused right Oh my God.
So you're finding the perpendicular bisectors of each line of your triangle. My black lines are those perpendicular bisectors. My red arc marks are how I'm finding the perpendicular bisectors. Once those perpendicular bisectors intersect at this green mark right here, that is the center of my circle. It is not smack dab middle of my triangle, but it is the middle of my circle that I'm going to create. So as my blue lines, which are these light blue lines, they are the perpendicular bisectors. And then once you have that circumcenter, you can draw a circle around your triangle. And that is a circumscribed circle. Circumscribed triangle. Okay, we're going to add to this the idea of an incenter. So we're going to look at the angle bisectors of a triangle. And it's where the angle bisectors of a triangle intersect at a point that's equidistant from the sides of the triangle. So if you look at our diagram, these three sides, PY, PX, and PZ, are all equidistant. And that's called the incenter. The way I remember this is it's angle starts with the vowel and incenter starts with the vowel, and they're both kind of small words versus perpendicular, bisector, and circumcenter. So if we look at how this applies to our math world, we know that GE, this guy right here, is 2x minus 7, and GF is x plus 4. Because we have the incenter, we know that GE is going to be equal to GF. So we can say 2x minus 7 is equal to x plus 4. And we're going to subtract x from both sides. And x minus 7 equals 4. Add 7 to both sides. And x equals 11. That is not our final answer. It is asking us what is GD. So we're going to plug this distance right here. So we're going to plug 11 into, I'm going to pick this one because either one of these is congruent. So it's going to be 11 plus 4. So GD is 15. Okay. If we are going to construct an incenter, we first start with a triangle. Then we're going to find the angle bisectors of each side. So we grab our compass, put it on our vertices, open it up, draw our arc, then we take, and where our arc meets the side of our line, we're going to draw another arc. And then where those two arcs cross is our angle bisector. So let's make that a green. And then we're going to do that to all three angles. Here. And draw an arc. Then where the arc meets, we're going to draw the arcs in the center. And then pick it up, put it to the other side. Where those two arcs meet, the line's going to go through that. Then we're going to do that to our remaining side. I'm going to go ahead and clear out our marks so that you can see a little bit better. So we're going to take our compass, take the arc mark, and then move our compass to where it crosses in the center. And then draw the line that goes through the vertices. Okay, and where that center happens is going to be the center of our circle, and our circle is going to touch each of these three sides. So let's go ahead and draw that circle, putting our point on the center. Got to get our, we're going to inscribe the circle. So it's going to go all the way around. And now I clear away my arc marks. And I can see the circle inscribed in the center.